Hi, I'm Benito Fernandez, and I'm going to speak to you today about the NuSTAR mission. The Nuclear Spectroscopic Telescope Array, or NuSTAR, is the first telescope in orbit that can focus high-energy X-rays from 3 to 79 keV. This is much higher than what was done previously, which was between 0.1 and 10 keV. This means the NuSTAR telescope can capture amazing things like remnants of an exploding sun or a star being born, things that previously eluded astronomers and their telescopes. The NuSTAR satellite was launched on June 13, 2012, from the Ronald Reagan test site in the South Pacific. Scientists developed and launched this satellite with the following goals in about a 10-year deadline. First, probe activity farther away than previously studied. Second, study the sources of hard X-ray emitting objects in the galaxy by mapping the central regions of our Milky Way. Number 3 was to study non-thermal radiation in young supernova remnants. 4 was to observe blazars, which are a type of galaxy powered by a black hole. And number 5, observe line and continuum emissions from core collapse supernova. The story of getting the satellite into space is an incredible feat of collaboration and technological development. They had to improve technology and build the device, which is basically a collapsible cell phone tower that puts itself together when in orbit. To actually get into orbit, the satellite was attached to a rocket. This rocket was called a Pegasus rocket, so it flew extremely fast. That rocket was flown up to 30,000 feet by a massive plane called an L-1011. Then, from the underbelly of that plane, the rocket released and shot itself into space. It's incredible. This all cost $160 million, which according to the head scientist Fiona Harrison of Caltech, is a reasonable sum to get a satellite into orbit. The typical cost of a satellite launch, according to Globalcom, is a $290 million average, and this can go as high as $500 million. This is the video of the mast actually extending from the satellite. The reason this satellite can do what previous iterations could not is the change in principles behind the device. Instead of working on the idea of a pinhole camera, like satellites before, it reflects light using mirrors into a focal point, so the definition of the image is much higher. Scientists set out to launch this satellite with the goal of bringing the high-energy part of the universe into focus. Old X-ray images used to look like this: pixelated, not very much in focus. NuSTAR's images look like this. The device has caught amazing events, incredible ones, like pulsating at the center of our galaxy. It's believed to be a radio pulsar, which is an extremely magnetic neutron star moving in a circular motion around its axis. It radiates magnetically from its poles, like high electricity beams. It also has detected a magnetar, which has an extremely strong magnetic field emitting gamma rays and X-rays. In other words, this device is catching high-energy events throughout the universe. NuSTAR has also confirmed that black holes do not emit light, but they do pulsate with some regularity. Like previously theorized, black holes captured by NuSTAR do not emit light, but instead absorb it. This, at the same time, they pulsate with some frequency as well. So, while we won't know the full results of this mission until the end of its decade-long lifespan in 2022, so far what we have seen is a major success. The NuSTAR mission is a great example of what dedicated astronomers can accomplish, and I'm excited to see the findings it makes in the rest of its operating life.